Okay, so we're going to continue on, and the next section that we're going to look at, we're going to be skipping a couple sections, and we're going to go to section 411, which is displacement diagrams. So displacement diagrams, this is going to start on page 98. Now, a displacement diagram is going to be a graphical plot of follower displacement relative to the driver, okay? So what I'm going to do is, most of you had me for computer programming, okay? And even if you didn't have me, if you had another instructor, you would have done this particular example. So it might strike a, you might remember it. So I'm going to go back to Module 1b, Part 2, Position Displacement Analysis Learning Plan. And there are two files here. One is going to be the inline slider crank model. This is a PDF. I'd like you to download that. And then you're also going to notice that there is, now it says assignment for inline slider crank. This is an Excel spreadsheet. It was actually assignment 4 back in our computer programs class, and you want to download that as well. That's my version. When you did it with me, if you kept those files, you probably have yours. And what we want to do is we want to open those up. So I'm going to go to my downloads, and I'm going to first click on the PDF, okay? The PDF of the inline slider crank model, okay? So I'm going to zoom out a little bit here, okay? And we're just going to kind of walk through this PDF, this handout first. Now, this is a kinematic diagram, but it's in different stages for an inline slider crank mechanism. So over here on the left-hand side, this would be the kinematic diagram when we have a slider crank where we have everything in line. And what that means is that the travel of the slider is in line with the center of rotation for the crank. Okay, there is no offset, it's in line. So as we look at this, the position that we see here for all the way over to the left-hand side, this is where we have the crank, which is 1 inch long, plus the connecting rod in line with one another to their furthest extreme position all the way at the very top here. And we call this top dead center, okay? Top dead center. If any of you have ever worked with like engines, top dead center is when that piston is all the way at the top, and it's in this configuration where the crank and the connecting rod are straight up and down, okay? So it's the furthest extreme position. Now that's what we're calling 0 degrees on our crank angle. Even though this crank is in what we would normally say is a 90-degree angle, we're starting here with the cycle, if you would, of one rotation going counterclockwise. And this is like 0 degrees. This is the start of our cycle. This is the start of the rotation of the angle. Now, you're going to notice that in this next position here, we have rotated the crank counterclockwise 45 degrees. And in doing so, we end up pulling the slider down a little bit. So you see that we went counterclockwise here on the crank. And then based on the travel of that slider, it's going to come down 0.377 inches. We call this the displacement, okay? So this would be slider displacement, how much it displaced, 0.377 down from its original position when the crank angle rotated 45 degrees. Do you see that? Okay. So if we look back at our PowerPoint presentation, oh, I'd have to go out of here. If the PowerPoint presentation said that a displacement diagram is where we look at the displacement of the slider versus the crank angle. And that's what we have here. So now we're going to move that crank another 45 degrees so that we're actually going to be 90 degrees from the original 0 position. And now you're going to notice that in this case, that slider moved down from the original top dead center 1.172 inches. So that is going to be the corresponding slider displacement at that new crank angle. Adding another 45 degrees, you're going to notice it's going to come down a little bit more. And then lastly, when we have it at the 180-degree mark, it now is down at its nearest limiting position. So this is going to be then its closest position down when we have the overlapping crank and connecting rod. So this is what's happening as we're kind of recording things. Now, let's look at the Excel spreadsheet. So if you open up the Excel spreadsheet, and I'm going to open this up. This might look familiar to you, but over on the left-hand side here, we have our inputs. This is going to be, I'm actually going to zoom in here. This is going to be the length of L2 and the length of L3. So if we go back to that PDF that we just looked at, L2 is 1 inch and L3 is 3 inches. So this spreadsheet represents this handout, okay? Now, as we go over to the right, this is going to be the crank angle versus the delta or the displacement of that slider with that crank angle. So at 0, crank angle 0, we have a displacement of 0. So if we go back over here, that means that we're at this first position, okay? Now, if we go down, now because it was a spreadsheet, we did the corresponding crank angle in 5-degree increments, okay? But we, on our handout that we just saw, we did it at 45 degrees, okay? So at 45 degrees, it calculated a value of 0.377, which is the same value that we see here. So when we move that crank 45 degrees and we drew it in its position, the delta or the displacement of that slider was 0.377, okay? So what I'm trying to say is that we have the spreadsheet and you can check your values with the different angles that you're going to be looking at. Now, if we go back over here to the spreadsheet, over on the right-hand side is the displacement diagram. So if we look here on the x-axis, this is going to be your crank angle in degrees. So this is the every 5-degree increments. And then if we go vertically up, this is going to be your piston displacement from top dead center. So this is going to be that delta value. So if we look over here, if we kind of estimate 45 degrees along our crank angle and we go up to where that would be, that's going to be our 0.377. So this is going to be the plot point. X is going to be the crank angle. Y is going to be that piston displacement. And that's what each one of these points are, okay? Now, as we go down and we go to the next one, let's go to the 90. 90 was at 1.172. So if we go over here, 90 degrees would be right about here, and then the 1.172 would be somewhere right in there. And if we go back to our handout, at the 90-degree mark, 1.172 was the displacement, okay? So this would represent the graphical, and our Excel spreadsheet would be the, if you would, analytical, okay? Now, what you're going to be doing for your homework problem is you're going to be filling in your L2 and your L3. It's going to generate the table as well as the plot, and you will be including this as a screenshot to kind of make sure that your numbers match what you graphically do for some of the positions. So for the next example, we're going to be looking at example 411, and I'm going to mimic for you the process that you're going to take to do the graphical portion and compare it back to the spreadsheet, okay? So you're not going to have to manually create a displacement diagram. I just want to make sure that you understand and know how it's generated based on the spreadsheet that we have here. So first things first, if we look at example 411, it's found, the problem statement is at the bottom of page 98. So down here is where the problem statement starts. But up at the top of the next page is where we have the illustration of the compressor piston arrangement. And then down here is going to be the kinematic diagram. Now, what we're going to do is we're going to draw this in an extreme limiting position at top dead center. So you're going to notice that we have the crank in line with the connecting rod and then the slider up on top here using the dimensions that we see. And then we're going to move it in a couple different positions and we're going to compare our displacement values to what we would get on the spreadsheet. So in this case, since L2 is 0.75 and L3 is 2, we can go back to our spreadsheet. I'm going to pull up the spreadsheet. Okay. And up here in the upper left-hand corner, my L2 is going to be 0.75 and my L3 is going to be 2. So it updated my values. I'm going to zoom out just a little bit and it has a new plot here. Okay. Now, what we're going to do is we're going to draw our initial position as we see it here in the arrangement where we have it in its furthest extreme position. So what we're going to do is we're going to go over to AutoCAD and we are going to draw the kinematic diagram. So I'm going to let you in the background. Well, I'm not going to, show you step by step because I think at this point you're probably like, we know how to do that. So go ahead and draw the kinematic diagram in the furthest extreme position here with the slider being directly above inline. Now, whenever we do any displacement diagrams, we always show and we always find the extreme positions, and if you would, your start angle becomes that 0 degrees, which is going to be one of the extreme positions. If you draw this in one of its, random middle positions and you start there, you're not going to get a diagram that starts and ends at 0 degrees. You're going to get like little tails at the end, or it's going to look weird. Okay. So our displacement diagram, as we look at Excel, will always start and stop at the top or at the bottom of our of our displacement diagram, okay? Because it's always going to go like up. This is the max from the position, and then it's going to come and it's going to start going back to its original 0 degrees. So think of this as like 0 degrees right here. This is like our 0, our top dead center. And then anything is going to be a displacement from that. Okay. Does everybody have their diagram all set in its top dead center form? Okay, so now what we're going to do is we're going to move this 45 degrees. Okay. So I'm going to move the crank 45 degrees because remember, a displacement diagram is crank angle versus displacement. So we're going to move that crank 45 degrees. So I'm going to do a rotate. I'm going to select that crank, zoom in here a little bit. I'm going to hit enter. And then I am going to select my base position, which is going to be the center at A there. Now, if I enter my angle right here, it's going to rotate that to the new position and not leave a copy behind. So notice down here, remember I have the copy option. I need to do C, enter, and then enter in my angle of 45 degrees. Okay. Now I'm gonna not move B or the joint, because we're going to be doing 90 degrees, then 135, then 180, and we're going to put them all in the same diagram. And if we keep putting the B's and the C's and the dots, it's going to get hard to look at. So we're going to just kind of move these to the endpoints and we're going to measure it that way. So we're going to keep track of it. Now I am going to change this to object 2. So it's a new color and a new line style. And then on the endpoint, change it to object 2. On the endpoint here, I'm going to do a radius circle. And I need to do this to 2-inch radius because that's going to be the length of my connecting rod. So now I'm going to do a line from this endpoint to the intersection of the vertical line that's here. Even though that vertical line is along that link, it really is the path that this is taking. Okay. So now I'm going to get rid of this diameter. And now this new position right here, the endpoint, is how far that slider moved down from top dead center. So I'm going to go back to my notes layer and we are going to do a linear dimension from, and I might go from that line to the endpoint there. Okay. And this would be a vertical dimension, and I'm going to move this up over here. There we go. So 0.2913 is my slider displacement from top dead center. So if I go back to Excel, okay, now I moved my crank 45 degrees. If I look here, my displacement, my delta is 0.291. And that's exactly what I measure on my AutoCAD diagram, 0.2913, right? Okay. You should get that same value if you did it correctly. So again, I'm going to be putting in about 3 more, movements here. So I'm not going to add my joints and I'm not going to add the letters because it would get way too cluttered. Okay. If you wanted to, and then change the size of the lettering and stuff like that, if you want to do that, you can, but you don't have to spend the time on that. Okay. So now we're going to rotate our crank another 45 degrees. So I'm going to go to rotate. I'm going to select my crank from the position that it's at, hit enter. Its base position is going to be the center at A. I'm going to hit C to leave a copy behind, and I'm going to hit 45 degrees. That's my new crank position. Now through the endpoint there, I'm going to draw a circle with a radius of 2. And I need to change my object actually, I need to add another object layer. I want to make this a new color, so I'm going to do object 2, and I'm going to change it to object 3. I'm going to make it cyan. Okay. So we're going to change this to object 3. And now I'm going to change this new position to object 3. And I'm going to do my line from the endpoint of that new position to the intersection I just created with that vertical line. Okay. There we go. And now we're going to go back to the notes layer, and I'm going to dimension from there to there and 0.8960, 0.896. So if I go to Excel and I go down to 90 degrees, 0.896 is my displacement from top dead center. Okay. Now, again, I'm simplifying this one, and when you do yours, it's going to be number 70 as your homework problem. You can simplify it to this point. Your original has to have all the labels with the standard joint callouts, but then anything that you move, add a different color, and you go to your endpoints. Does that make sense to everybody? Just otherwise, because it's going to be otherwise craziness. You won't be able to see anything. Let's do one more just to be sure we all know what to do here. So I'm going to add a layer. Object 4. And I'm going to change this one to the magenta. Now make sure that these are viewable on a dark background or viewable on a light background, depending on what you're working with. Okay. So now I'm going to do one more rotate. Base point is going to be at A. I need to do a C for copy, and it's going to be another 45 oops. Oh, 5 degrees. That's not what I wanted. Let me get rid of that. Let me do it one more time. I'm going to do a rotate. This one, enter. Center for the base position, C for copy, and then 45. There we go. So there's my new position. I'm going to put it on the object 4 layer. So it goes to magenta. And then now I'm going to draw a radius equal to the 2 inches. And where it crosses that vertical line is my new position. So I'm going to do a line from here to there. I'm going to get rid of that radius. And then I'm going to go to notes, linear dimension from my new position to the top, 1.319. I'm sorry, 1.3519. So if we go to our spreadsheet at 135 degrees, it's 1.352, 1.3519, right? So same thing. Okay. And then you would, continue however many angles you would want to continue to do. All right. So this one, you're going to want to make sure that you add the label of example 411. There we go. So any questions on that one? Now to hand this one in, screenshot here of your different positions. So we did 45, 90, and 135. And so you have these dimensions on here. These are linear dimensions. And then you're going to take a screenshot of the spreadsheet here, okay? And you need to change your L2 to match this diagram, 0.75, your L3 to be 2. And you might have to do, see, I'm gonna make this one. You might have to do, 2 screenshots if when you copy it, I can't see everything, because I have a feeling that if you try to do one screenshot here of this, we might not be able to see all the numbers. Okay. So kind of play with that and see what you think. So at least one screenshot, but it might take 2 to get this on here for example problem 411. Okay. So any questions on displacement diagram at this point? All right, so you don't have to generate the displacement diagram. You're going to use my Excel. You're going to put in the proper lengths of links 2 and 3. And then you are going to be drawing graphically some positions, and we'll look at the assignment for the ones that are specific to the problem you're going to be doing there. But for this one, you just need to identify the 45 degrees, 90, and 135, and then have their corresponding values up here. Okay. All right. So that takes us to the end of our PowerPoint presentation. So if we look here, I'm going to go all the way down to the bottom. Our very last example was example 411. So we plotted that using Excel, we plotted the displacement diagram, and then now you'll just hand in the screenshots. So I am going to stop recording here, and then I'll do another recording for an overview of the homework.